All right, so we're back in the lab. Internet's still down. I reported it to Spectrum. And even though I let them know that there was someone here in the box outside here by the street, and they left, well, we have someone coming out tomorrow, so to take a look. Anyway, at least we got someone tomorrow to come look at it, and I'll be able to get prorated the bill, hopefully. This, guys, is a picture of from the recent. This is from the Mars rover. Actually, that's not a good. Let's change this up a little bit. Yeah, there we go. So that is from the recent Curiosity rover photo, which I think is just epic. And what they did is it is now sort of exploring those formations here, which is awesome. I tend to follow space stuff, but anyway, we had to change our background. Can't download any, so I had this on my hard drive. Let's go back to the lab I was just doing, though. However, this is, we've been working on, we're working on DMVPN tunnel types. We just did a DMVPN tunnel that was clear text, a very basic tunnel using RIP as the IGP. And I want to go back to that one for a minute because I had a chance after the lab session to kind of go back and review the workbook. And in the workbook, it talked about, well, there's one requirement that I missed, essentially. And that is I missed the default route. Because what was happening, and I'm not sure that this is what is intended based on what I was reading in the lab key, that this is supposed to be a very generic tunnel configuration. In other words, these tunnel endpoints are not really supposed to form adjacencies to the other. In other words, they're not supposed to form GRE tunnels spoke to spoke. And let me just double check my tunnel configuration here because I think I'm missing something. I'm going to look at the lab key on my phone here. I believe this is right. Yeah, so router 1, it says that, okay, I have the IP NHRP map and the map multicast IP NHRP NHS, right. Now, a statement was made that by the way, in the RIP configuration, I did not have to do this, apparently. No passive interface, tunnel 0. That's not supposed to participate in RIP. What happened is RIP is by default redistributing connected. So, but that all looked good. Yeah, this is correct. But I think if we do a default route, then we're not going to form, like right now, if I do show IP or show DMVPN, yeah, I don't think I should have peers. I should only be peering to router 5 as the hub. That's the intention anyway. This could be a difference in code versions, I'm not sure. But let's see what happens when we originate a default route into from RIP. Default information originate. Now that may change things. Then let's go to clear IP route star. Clear. Can we do NHRP? We can. Nice. Okay, so now we only have router 5. Show IP route. Now we have a default. Okay, now notice now I think the next hop here should be router 5. Let's see. Ping 150.1.2.2 source L0. Yeah, see, I don't think that's how they intend it to work. Let me look at the key here real quick. Yeah, show run, let's see. Show run interface T0, include map. That's correct. So router 1 should not really be learning. Everything should be coming from router 5. So something is wrong with the configuration here. I wonder if it's because of split horizon. Interface T0. Okay, maybe that's the issue. Clear IP route star. Clear IP and HRP. Let's do that here as well. All right, show IP and HRP. We just have 5. Show IP route RIP. Yeah, see, that breaks RIP, so that's not the answer. Well, let's see. Gotta give RIP a minute. Show IP protocol section RIP. Show IP RIP database. Okay, he should at least be sending a default route. Okay, that's not allowing something to work. Maybe that's not allowing, so let's turn that back on. All right, let's do this. Show run section RIP. RIP is so slow to converge, man. Okay. I'm going to take this. I'm going to do no router RIP. All right, we don't need that. Okay, we're going to do this. And we're going to go to router 5. Interface T0 IP split. Slow down Q. Slow down. Okay, now we're going to do this again. Debug IP packet. Debug IP RIP. So we're learning about sending update, but we're not receiving any back. Because we're sending multicast, yeah, that breaks, that essentially breaks multicast. Multicast over the tunnel interface. Not true multicast, we know. NHRP should resolve that though. .150.1. Yeah, we're not getting anything because of split horizon. That should be okay though. I think that's a default, right? Show run interface T0. Yeah, the fact that it's not there means that that's the default. IP split horizon is enabled. So what do we have going on here? Let's do Okay, received update. But ignored V2 packet from one of our own addresses. Sorry. I'll pause. Hello? Hello? Survey question. No, thank you. I do not want to take a survey. All right, so receive V2 update. All right, so I'm receiving updates. So if I do show IP route, yeah, I'm learning the updates from router 1. Routers, but he's not receiving them because router 5 somehow thinks when it forms a RIP packet to send. I wonder if I have that on the wrong interface. Let me double check my... It's so annoying that they would call me right away. I'm already triggered. That Spectrum would call me right away. Yeah, it's ignoring a V2 packet from its own address. But it has not received it. Yeah, that's odd. There's definitely an issue there. That could be a... Maybe that's a platform issue. But I'm looking at the configuration that it has for router 5 in the lab key. Yeah, it says nothing about enabling split horizon, but sure enough, weird. Yeah, it builds it, and it tries to send out an update, but it can't because it perceives that. Wait, sending V2 update 2 via loopback 0. So if I do show DMVPN, wow, it's none of the tunnels are showing us up here. It's almost like it's sending to this multicast address, and it's sending it to itself and saying, I'm ignoring this from myself. Problem is, it's never receiving it on router 1. Yeah, it's never really sending it. Let's turn on, let's see what's going on here. Let's look at let's do some Wireshark troubleshooting here. So we need to go here. That needs to be over here. And we're going to do a capture on router 5. And we're going to see just what the heck is going on here. What in tarnation? What in tarnation's happening here? All right. Traffic capture. Everything. And we're going to remove this one. So yeah, folks, while we're talking about that, I will not have internet from my desktop until tomorrow morning at the earliest. So anyway, you'll be seeing this stuff a day late. I know, I'm glad you're not holding your breath, right? All right, so let's see what this thing is doing. Let's remove RIP. Well, RIP is not even the problem here. When we turn on split horizon, it actually broke NHRP, I think is what happened. Show IP NHRP. I got nothing. Why is that? See, I think, okay, I think what's happening is the lab key says that split horizon is enabled by default. And that is not the case on this platform. Let me just verify that, what it's saying here. Yeah, I don't think this is DMVPN phase 1. I think it's where it talks about RIP. Note that it's a multi-point tunnel, is not a multicast tunnel. That is true. Okay, multicast is added to the spokes with the command IP NHRP map multicast. All right, this says dynamic. Yeah, 169.254. That's the public address, quote unquote. That is correct. Okay, in this specific design, RIP v2 router is used with split horizon enabled on the hub's tunnel interface, the default behavior. Yeah, that's correct. It's the same as what we have here. However, because the hub has advertised default route to all the spokes, they do not need the specific routes about each other. All right, maybe this is an order of operations thing. What I'm going to do is I'm going to take the configuration off router 5. I'm going to even just take the tunnel down. Something is wrong here. No interface T0. Show DMVPN. Yeah, I got nothing. I got nothing. I don't get it. Interface T0, we're going to say IP. So maybe it's not related to that at all. Okay, now I'm really confused. All right, we're going to put that back to default. And show run IP redirects. That is default. I did not put that there. IP and HRP authentication, HRP auth, IP and HRP map multicast dynamic, IP and HRP network ID 1, tunnel source. Well, let's shut the interface down. Ping 151.0.1. Yeah, show IP internet brief. Ping 169.254.100.1. Okay. We're going back to basic troubleshooting here. Layer 1, layer 2, we're good. Looks like layer 3 on the sub interface is good. Let's go tunnel interface. This is not going to work though. Why will the tunnel not come up? It was working a minute ago. All right, let's look at our captures, because are we sending NHRP packets? Well, no, are we sending GRE packets? Let's do a little troubleshooting here. Something is definitely wrong in the lab. Something is awry in the lab. All right, we're going to rename this. We're going to upload this later, folks, for your enjoyment. Basic plain text. And actually, we're going to delete that. That's router 2. That's the last. And we're going to decompress that. All right, let's see what router 5 is doing. Let's look at the best way to troubleshoot, right? All right. So I'm looking for, all right, here's a ping, recent. I should see NHRP. Did I see it from the beginning? All right, who is sending, this is starting to bother me here. I have no idea who is sending DHCP. Who is this guy? Who is this source? FA163EB3291E. We're gonna go off on a little tangent here, all right? But this is good. This is good. This is some basic troubleshooting skills here. All right, this is a DHCP discover packet. Show. Let's see who this is. Show MAC address. FA163EB3291E. It's not him. Let's ping. Well, what interface did this come on? It's a broadcast, so we don't know. All right, let's see. Let's get to the bottom of this. Show ARP. Wait, ARP is only going to show IP interface. Show IP interface brief. I know how to do this on a switch. Show MAC address table. Router's different, right? FA163D89C4. Is it more than one? Here's a DHCP discover. It's multiple. This could be coming from link local. Yeah, this. Another IPv4. Oh, well, I'm not going to worry. There's a lot of them. All right. So, am I not generating? Can we do a debug here? Maybe that's easier at this stage. Debug. NHRP. Interface tunnel 0. Shut. No shut. No NHS is configured. I didn't think we had to do NHS on... Do we not have that here? IP NHRP NHS is here, but we don't need that on router 5. Why does it think it needs NHS? Let me make sure. Yeah, why does it think it needs no NHS? Unable to send registration, no NHS is configured. Let's search on the phone here. No NHSs. Relevant configuration. Hub. IP, yeah, no IP redirects is default. As soon as you create the tunnel interface, it does, which makes sense. IP NHRP, let's look at the configuration. Show run interface T0. IP NHRP authentication, IP NHRP map multicast dynamic, IP NHRP network ID 1. Tunnel source, gigabit 0100, that's fine. Tunnel mode, GRE multipoint. Tunnel key 2. Yeah, it says nothing in here about show IP NHS. Not a valid command here, it says. Okay, it looks like here it might be telling me of debug explanation. Okay, good, good. Does not have a next-hop server configured. The hub is the next-hop server or DMVPN. This is expected. Okay. Let's do a debug. We're already doing debug NHRP. Okay, this was working. So what I'm going to do at this stage is I'm going to reload. No. Yes. I mean, I don't know what else to do. Everything was up, and then all of a sudden, maybe it's an issue with viral. Maybe it's a bug in the code. I don't know, but I'm just kind of spinning my wheels at this stage. So what we're going to do is we're going to turn this off. I mean, seriously, that I don't know what else to say. All right, we're going to watch this baby come back up. We're going to reconfigure it. And what I'm trying to get to is from the last lab, the default route. So we'll see what that says when it comes back up. The next thing I was trying to work on is taking the same tunnel, and we want to add IPSec. And let's work on that while we're waiting on this thing to boot back up. I probably should have darn it, I should have done a show run. I'm sure I have that up here somewhere. Let's just save all this. So show, all right, we're gonna, when it comes back up, we're gonna do this. Let's just call this router 5. I think that's what I have here already. Yeah, that's router 5. Then we're gonna take the rest of router 5 from our boot up configuration, which is here. Initial config for Advanced Technology Labs and DMVPN router 5. So we're going to copy that. We're going to copy that. Then we're going to do RIP. And RIP is just going to be router RIP version 2, no auto summary, passive interface default. No passive interface. Tunnel 0. Network 155.1.0.0. And that's it. So check on this guy. No. No, thank you. Okay, then while that's booting up, we're going to look at our next section, which is our the same configuration. We're just going to add a crypto policy, right? Crypto ISACamp policy 10, encryption AES 128, hash SHA 256. Group 16, I think. I'm going to wait. Yeah, I want to wait on this. The group I get, you know, it may be Diffie Hellman 16, but that could be a different group number. That may be group 16. We'll see. Now, this is the part that's going to be a little interesting for me, and that's the single pre-shared key. Because is that a single configuration? I think it is. But how is that done? Let's look at our hub example here. Shoot, I'm going to have to look at it on the phone because the other IPSec labs I did, the key configuration was to an IP address. Here we go, this configuration guide. It's address 0000. I'm not sure how else you would do that. All right, let's get router 5 going again and see if he behaves this time. Okay, that is that. Now let's put in tunnel 0. See what happens. I got nothing. Debug IPGRE. How did we do that? Debug. Oh, generic tunnel interface. Debug tunnel. I'm not sure what happened here, folks. I mean, packet decapsulated. Okay. Was I just being impatient? Tables are default length. Tunnel multi GRE IP to decaps was 205. The only thing I could, what I did not have different is this. No IP split horizon. The tunnel is up. We don't need to decap. It's NHRP that's not working. No NHS is configured. Yeah. Interface T0. No IP split horizon. No NHS is configured. I don't get it. IP, NHRP, NHS. What's the purpose of having that on the hub? Yeah, now it's like locked up on me. Okay. All right, definitely something wrong with the lab here. Well, we had internet for a second. I don't know what's going on anymore, people. All right, ping. Turn the wireless off. Okay. Yeah, something just happened to the viral host, so we're just going to reboot it. Maintenance. Shutdown system. Yes. When in doubt, just reboot, right? Let's see what happens. Lab was working so well. That's okay. While it's doing that, we're going to get our we're going to try to get our IPSec configuration ready. Do a little maintenance here. Okay, stop. We're going to start again. Ubuntu. All right. Continue our maintenance here. Delete that. Okay, good deal. We can delete Kylo Ren. You can go away now. Where are you? Okay. Yes, so while that's booting, we're going to look at the IPSec configuration that we're going to need over here. So we're going to have to say router 5. Crypto ISACamp policy 10. Encryption AES 128. Hash 256. Group 16. And then crypto ISACamp key. What is our key going to be? Oh, it wants to create a specific policy name. No, it doesn't. The key name is DMVPN underscore PSK. Oh, we need our authentication. That's what I forget sometimes. Authentication, pre-share. Crypto key is that, and address is 0.0.0.0. It was cautioning us against this, but I don't know how else we can do it. Okay, so that's the key. Then we're going to do crypto IPSec profile, DMVPN underscore profile, encryption AES 256, authentication SHA 512, mode transport, tunnel mode, I think. And then all we do is underneath the tunnel interface T0, we say the protection. What is a protection? It's on the desktop here. Tunnel protection, IPSec profile, yeah. Tunnel protection, IPSec profile, DMVPN underscore profile. I think that's all there is to it. And we do the same thing on the spokes. Yeah. So we would, the only difference is on the spokes. So we'll call this our IP. And let's see how our, okay, this should be loaded. So let's get our topology going again here, folks. Okay, simulations. Launch a new simulation. We'll load this file again. Launch. Okay. On the road again. So on our IPSec config, again, all we're going to do is add this. So we'll say router 1. And everything will pretty much be the same, except this will be our template. Except for the tunnel key, crypto ISA KMP key. This address is going to be the tunnel overlay IP 5.1.0.5. I believe that's what we need there. Yeah. I'm taking a risk here because something will probably be wrong with the config. So I'm just gonna paste out 5 and 1. All right, so let's see how these things are doing. Let's see if they're on their way. Okay, good. This is how I used to do it before I used the ini-git repository. I'd wait for all the routers to boot, and I'd say no, and then I would copy and paste in the configuration from Notepad, quote-unquote Notepad. Let's get ready for that. I think this is going to be the same topology. I believe this is just the same topology. Let me look at the requirements. DMVPN with IPSec. Yeah, the topology is just DMVPN. So if we look at our files, Got our viral. Yeah. This is all we need here. So, all right, waiting on these routers to boot up. I'm going to shut down the other routers. Sometimes whatever you do, whenever you start and then stop the viral server like that, it doesn't release all the memory. So we're going to go ahead and be preemptive here. So yeah, we just need routers 1 through 5 for this particular exercise. We'll leave that up. Full screen. And yeah. By the way, I can highly recommend, folks, the last night, kind of a Friday night thing, we went to a movie. We saw The Shape of Water, directed by Guillermo Toro. Yeah, Guillermo Toro. Great movie. Really well done. It's up for, he won Best Director at the Golden Globes. It's Oscar season here in the U.S., so, you know, we're catching some of the movies that are going to be up for awards, most likely. Always makes it more fun when you watch the actual awards. Just kind of a side note. All right, so that is Web Insta-Kill, okay? No. 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 All right, so we're going to get the CPU hog thing for a little bit. Here's router 1. Yep, we're going to get this for a little while. All right, so I think we have all our configuration ready. So just taking a step back, our goal now is to see if restarting the routers, all of them, will resolve this issue with NHRP. For some reason, NHRP just stopped working. So we're going to try to fix that first. In fact, if I go back, let me look at my configuration here. Yeah, this is going to be our tunnel 0 for router 1, for example. And RIP. Yeah. So interface tunnel 0. IP address, no IP redirects. That is default. I think it's going to put it in there. That's fine. Authentication. NHRP map. NHRP map multicast. You know what I might have been missing? No, I don't think so. Anyway, wait for this to come up. All right, this is up. So we're going to put his base config in there. And the same on router 2. Router 3. Router 4. And router 5. Okay, now we will start with router 5 actually. So let me find that notepad. Yep. All right, we're not going to worry about RIP yet. IP and HRP authentication. IP and HRP map. Multicast dynamic. IP and HRP network ID 1. Tunnel source. Let me just sanity check this. Any sanity I had all went out the door. Authentication in IP and HRP map multicast. Blah, blah, blah. Tunnel key. Yep. Blah, blah. Okay. So let's do that tunnel interface and then just router 1, and that's it. So this is router 1. Tunnels come up. I should at least. What was so hard about that? Okay, the server just froze, I guess. All right, that's router 1. Let's do router 2. The only difference is that. And router 3, we should get an error here. Interface tunnel 0. IP address. What was wrong with that? I swear. Cisco router, sometimes you make me doubt my own sanity here. Okay. Good. So now we should show IP and HRP. Beautiful. That's what we want. All right, now let's do our RIP routing. And this should be the case for all of them, except on router 5. We want to do default information originate. So let's just do router 5 and 1 first. Okay, received update. So now we have routing information from router 1. Finally. Is this just buggy or is this just a one-time coincidence? I guess we're going to find out as we're going to be working for a while on DMVPN tunnels. But man, that is, what a pain. Okay, undebug. So now here we just have a default route. So now we're back to where I was about an hour ago. What we want to see is if by using a default route, by sending a default route from the hub to the spokes, if we prevent the spokes from forming spoke-to-spoke tunnels. Let's find out. Router 2, router 3, router 4. Give RIP its own sweet time to converge. And then we will do show IP route RIP. Okay. Now notice here we have a default route to tunnel 0 as the egress interface. The next hop is 155.1.0.5. 5 should be establishing show run. We don't have the next hop configuration here. Or is that on the spokes? NHS, next hop self. Yeah, I think we have that on the spokes. Yeah, that's where that belongs, on the spokes. So, all right. Good deal. So now, if I try to excuse me, ping 1.0.150, the loopback, 150.1.0.2.2 source L0 trace route. Yes, that's what I want. Okay, this is the simple. The key that I was missing in the last lab was the default route. So by adding the default route in RIP, we summarize the information and we just have spoke to hub or hub to spoke. We have no spoke to spoke tunnels. Just good. At least it's, I mean, this is, in the words of Brian McGann in the INE video, it is a obsolete design. But we have completed the requirements of the last lab, finally. Now we can move on to DMVPN with IPSec, which all we're doing is we're changing the tunnel, we're adding encryption, right? So it'll be GRE over IPSec. This will be the encapsulation will be an or not the encapsulation, but the payloads will be encrypted with IPSec. We're going to use transport mode so that the encapsulation is still GRE. All right. To save on overhead. And to do that, now we've done that. We get rid of that guy. We can get rid of this guy. Let's bring back some of the work we did while we're waiting on Viral to reload. It was not completely wasted time here. This is our tunnel configuration. So let's start with router 5. And what we should expect is that these will go down. Also, I think we are doing away, in these requirements, we're doing away with the default route. Let me check that part first. Let me double check that in the requirements of this lab. Yeah, DMVPN with IPSec. No, it will still advertise the default route. Okay, good deal. So let's regardless do router 5 first. Well, let's do a spoke first. We're just going to bring down, essentially this will bring down the spoke 1 to the hub 5. You know, it only bring down spoke 1 connection. And we're going to do, in fact, it might make sense to do, yeah, let's do that. Let's do router 1 first. So we're going to go crypto ISACamp policy 10, encryption AES 128, hash SHA 256, 256, okay. See these spaces and hyphens, group 16, okay, that works. Authentication pre-share. Then we do exit and crypto ISACamp key DMVPN PSK address and crypto IPSec profile, no hyphen, DMVPN underscore profile, encryption no, this is, we need to do what am I missing here? Set. We need a transform set, right? Right. Crypto. So we do crypto IPSec transform set AES 256 SHA 512 and AES 256. I need to check this. Crypto IPSec transform set AES 256 SHA 512 AES ESP AES 256. Okay. SHA ESP SHA 512 HMAC. Okay. This part, it always gets me. Then we do boom boom. Crypto IPSec profile DMVPN underscore profile set transform set AES 256 SHA 512 and I'm missing something here. Set where do we put that it's going to be thought it's transport. Maybe it's under the transform set. Crypto IPSec transform set. AES 256 512 ESPA. Yes, what's wrong? Crypto mode transport. Okay. So this needs to be mode transport exit. Mode transport exit crypto IPSec set transform set okay, and then all we do, I think we have all this set. Boom. All right. Show run crypto. Let's just double check our work. Let's just validate. Policy 10 encryption AES. I'm assuming 128 is the default. Let's check. Why do you do me like that, parser? Okay, 256, group 16, authentication, crypto address, ESP, AS256, SHA-512, mode transport. Okay, then show run interface T0. Okay, good. So now our tunnel should be down, but still up. Can we send traffic that way, though? No. Okay, just making sure. Now let's go to router 5 and add this. And will it be any different? No, it should be exactly the same. I didn't like something. Crip. Try that again. Let's try that again. The difference here is a key. Crypto ISACamp key DMVPN PSK 0000. It doesn't remove the other one. Which we should manually remove it, yeah. But the tunnel should come up with router 1. Uh-oh, crypto processing information mode failed with peer. Okay. I may be using the wrong, I may have to, it could be that I need to use the underlay. Show crypto ISACamp PSA. Mem no state active, okay. Debug crypto ISACamp PSA. I can do peer. Receive packet, not an IPSec packet. yeah. Let's just troubleshoot crypto here. Okay, here's router 1. Unduplicate during call. Now pre-shared key matching, that's 02. Okay, yeah, it looks like we need to do the okay, we should have all we need, but it looks like we're seeing some information here. Sending packet to my port. Processing of informational mode. Not sure what that means. Actually, it's debugging on router 1. It'd be easier. Yeah, instead of looking at router 5, we know that 2 through 4 are not going to work, so it makes more sense to debug in router Router 1. Okay. Destination port 500, source port 500 global, no state. No cert or pre-shared address key. Okay, so the keys are using the wrong address set. So it looks like what we need to do here, 169.254.100.5. That's probably the problem then. Let's try that on router 1. Okay, we're getting farther. IPSec process complete, phase 1. Good. That was it. Show run section crypto. So we need to take this one out. That was a problem. Okay, not too bad. We overcome. Ping 15105, source T0. Yes, good. We have encryption. Good. There we are. Boom. All right, so now we just need to apply this on the other routers. 2 through 4, and we should be good to go. These guys went to sleep. They're like, yeah, we're done. Taking too long, man. We're done. Okay, router 3 and router 4. Sweet. All right. Now everything should start to look normal. The only difference is we have encryption. Instead of plain text, we have encryption. There should be really no other difference in the behavior of... hold on. Receive packet, not an IPSec packet. All right. Hopefully still just some convergence. Show crypto IPSec SA. Okay, maybe I need to generate some traffic. Do we have RIP still running? Okay, this is because we generated traffic across the tunnel. RIP can take forever, so let's just take matters into our own hands. 155.1.0. Or no, let's ping. Should time out initially. Okay, so we've got some sort of issue going on here. Okay, receive packet, not an IPSec packet. Oh, could this be show run section crypto? Address 0000, right. Ping 15103, source. All right, well, it doesn't look like... Crypto IGP. Oh, I didn't apply this, did I? I didn't copy the whole thing. Duh. That's the issue. Okay. Be careful with your copy paste. There we go. Now we're good. Now we're good. So now it should be show crypto IPSec. Crypto IPSec. Can I do a summary here? Here. Okay. All right. There we go. We're good to go, folks. Show IP route RIP. We should have a default. We should be able to ping that 1.3.3 source L0, and that will all be encrypted. Good deal. Well, it took long enough, but we have completed our lab with IPSec. And next up is going to be DMVPN phase 1 with OSPF. Oh my goodness. I've been warned about OSPF and DMVPN, so this should be very interesting. Anyway, thanks for watching, folks. Again, you'll be watching this a day late. I may actually be streaming right now as you're watching this, so be sure to check out you know, we're everywhere on social media. I'm everywhere, so we got me on Twitter, Instagram, but more importantly, Discord. That's an interactive server. If you've never used Discord, it's like a Spark or a Slack channel, but it integrates with streaming very well, in particular with Twitch. So check me out on the Twitch channel, Discord. They're all linked here, and of course YouTube. So please like the video if you enjoyed it, and subscribe if you haven't already. And we shall see you back here soon for the next lab, which will be DMVPN phase 1 with OSPF.